solving equations with variables on both sides. So in this lesson, we're going to try to solve an equation with variables on both sides, like it says. Remember, how to solve an equation is just trying to find the variable that's the solution to the equation. We use inverse operations to do that, right? So if there's a minus, we want to add to both sides to cancel out. If there's a multiplication, we want to divide both sides by it. We use the properties of equality to make sure it's all proper. And remember, the way we solve it is we kind of do reverse PEMDAS. And one of the key things is we want to simplify both sides first. And the only new thing when there's a variable on both sides is we want to isolate the variable on one side. Like we've said that before, but now we're going to also add and subtract variables from both sides. So like this part becomes way more important. And the best way to do it is just by examples. Let's do a couple examples here. So solutions with variable on both sides. What is the value of x in the equation below? So we're just going to solve this. So step one, let's simplify both sides. Right? So let's simplify what we can. So over here we're going to distribute that -2, and on the left side we're going to add the like terms. Don't forget there's an equal sign here. And normally whenever you do to one side, do the other side. The thing we're doing in this case is we're simplifying both sides. So we're not adding anything to both sides. When you just work on one side alone, you're just simplifying. So you do that. So 3x plus 4x is just 7x minus 10. And then on this side, equal sign, distribute. So I get -2x plus 8 plus 9. Right? -2 times x, -2x, -2 times -4 is +8 plus 9. Next, I'm going to take one extra step and we're going to simplify this. Right? So I'm going to add those two like terms. So I'm going to get this 7x minus 10 equals -2x plus 17. Okay, so now it's simplified. We have a variable on both sides. Next thing you want to do is you want to isolate the variables. You only want to have one variable. So typically you want to get rid of the smaller variable. So in this case, that's -2x. So the way we get rid of it is we're going to use the inverse operation, just like we do when we try to get rid of the numbers. So same concept. If I want to get rid of that -2x, I'm going to have to add 2x to both sides. So if I add the 2x here, it has to go on this side to the x portion. So whatever you do one side, you do the other. So plus 2x plus 2x. This side will cancel out there. Over here I get 9x minus 10 equals 17. And once you get that, you're back to having a two-step equation. Right, so if I want to solve this, I want to get the x by itself. So just add 10 to both sides. Whatever you do one side, you got to do the other. And now we have 9x equals 27. And then we're just going to divide both sides by 9. So x equals 3. So there we go. Let's do it again with the next one. So remember, step one here is we want to simplify if we can. Now there's a fraction, so it might change the thing. So remember, if you have a fraction, if you don't want to deal with fractions, the easiest way to do is just multiply everything by the LCD. So if I want to get rid of that 1/2, which right now is going to cause a little bit of a problem, we can multiply everything by the LCD, which in this case is just 2. We only have one fraction, you just whatever the denominator is, multiply everything by that. So we're going to multiply this guy by 2, this guy by 2, this guy by 2, and this guy by 2. So that's the easiest way to get rid of a fraction if you don't want to deal with it. Just multiply everything by 2. Now here, a lot of people overcomplicate it. These cancel out and that's it. You just have n minus 4. That's it. Over here, 7 times 2 is 14, so minus 14. Equal sign. -2 times 2 is -4n. And then 6 times 2 is 12. So we have this. So that's my equal sign. Now remember, we're still simplifying. I still have stuff I gotta simplify before I do anything else. Now here's a parenthesis, but there's nothing special anymore. We got rid of the 1/2, so it's all we have to do is add like terms. So I can add the -4 and the -14. Remember, anytime they're both the same sign, like in this case, -4 and -14, we're just gonna add them. So -4 minus another 14 is just a -18. And then on this side, I didn't do anything, so leave it alone. So now we simplify both sides. Right, next I want to get rid of the n's. You always want to do the variables before the numbers. So you want to have one variable. So I can either get rid of the n here or get rid of the -4 there. Now I know, normally I say get rid of a small number. In this case that's still true. I want to get rid of this -4. I don't like negatives, so I'm going to add 4 to both sides. So plus 4n. Whatever I do this side, I got to do this side. These cancel out, there's an equal sign. n plus 4n, remember if there's not a number, it's a 1. So it's 5n minus 18 plus equals positive 12. Like I said, I don't really need the plus there. So we have this, and now we just have a one-step equation. Get rid of that 18. Right? So we're going to add 18 to both sides. And then we carry it over here. So I have 5n, because these cancel, equals 30. And all I got to do is divide both sides by 5. And you get n equals 6. And that's the answer there. Right, so again, the reason I divided by 5 because remember these are being multiplied when they're right next to each other, so the opposite of multiplying is dividing. Okay, let's talk about some special cases. Understanding equations when we have infinitely many and no solutions. Let's talk about what happens there. So, same idea here, let's solve this, right? Here's my equal sign. Step 1, let's simplify first. So I'm going to distribute this 2 to both of them. So you get 4x plus 6. Just an equal sign. Over here I have 4x plus 6. You notice they're the same. And we'll talk about what that does in a second. But first percent you need to notice, so let's just solve it. So what would I do next? I would get rid of one of the x's. Down, they're both the same, so we're just going to pick one. Minus 4x to this side. Whatever I do to this side, I got to do this side. Minus 4x. These cancel out, and I get 6 equals 6. That's a true statement. 6 does equal 6. Anytime you get a true statement, it could be 0 equals 0. It could be like 2 equals 2. If it's a true statement, that means we have infinitely many solutions. All that means is that the x's cancel out. It didn't matter what we did. Only many solutions. So it's kind of like all round numbers. They have infinitely many solutions. It didn't matter what you plugged in for x. They all work. Every single value of x works because they cancel out in the end, and you got a true statement. So the general idea is if you have a true statement, your answer is going to be infinitely many solutions. All row numbers. Well, how about if you get a false statement? That's the next one. Right, so distribute this 2 to both of them. I get 6x minus 5 equals 6x plus 4. So in this case, they're not the same, but they do have the same variable. Anyway, let's just solve it and see what happens. So I'm going to get rid of the variables first. So let's go minus 6x on both sides. Once I get the other side, those cancel out. These cancel out. I know negative 5 equals 4. That is not true. That's false. So in that case, you have no solution. Does not matter what number you plugged in for x, you would not get a right answer. In this case, no matter what you plugged in, you would have got a right answer for x. You'd be like, oh, that's x equals 2. You get a true statement. In this case, no matter what you plugged in, it would never work. So those are the special cases. If you happen to solve it and the x's cancel out and you get a true statement, infinitely many solutions. If you happen to solve it and the x's cancel out and you get a false statement, no solution. Okay, let's do one last one. Let's do a little word problem here, a little application problem. Cameron pays 0.95 cents per song, oh man, Cameron, with his current music service. The new music download service charges 89 cents per song with a $12 joining fee. Should Cameron switch to the new service? Write an equation to represent when the cost for any number of songs is the same for both services. So we want to write two equations. So this is probably our first time practicing this. So here's the key. 0.9 cents per song. Song is our variable here. So song is like our x. They want us to use s. So this music service fee, the first one, is 0.95 s. My s's are pretty bad, I'm sorry. That's how much we're paying. For every song we download, we have to pay 95 cents. The other music service, it's on this side, we'll put on the right hand side here, it's 89 cents per song, right? So again, per song. So that's going to be 0.89 s plus $12 joining fee. So we got to add $12 to that. So plus 12. That's your equation, right? One of them is just paying 95 cents per song. The other one's paying 89 cents per song plus the $12 joining fee. Now this, we just got to solve it. We solve like anything else, right? Here's my equal sign. I only want one variable. I have a variable on each side right now. Let's get rid of one of them. Let's get rid of the smaller one, which would be this side. Minus 0.89s. Minus 0.89s. These cancel. 95 cents minus 89 cents would be 6 cents. But watch out. It's 0.06. Right, not 0.6, that's 60 cents. I want 6 cents. If you don't like that, you can always multiply everything by 100 to get rid of the decimals. But I'm just going to do this for now. That's an equal to 12. Now I'm trying to solve for x. Again, no, my s sucks, I'm sorry. So let's get rid of this 0.06 to get the s by itself. So 0.06, 0.06. These cancel out. I would probably need a calculator for this. So we get 200. So 200 is the break-even point. That means 200 is when it doesn't matter which service you have. It's going to cost the same for either one. So if you download exactly 200 songs, it doesn't matter which service you have. So that's how we interpret the answer. And that's the lesson.